Fantastic. Okay, right. We are on live. And
Ja, so die klank is reg, Q&A. You see there, we've just entered the question there.
yes, excellent. Right. And we have to start. Once again, to me, it seems as if the turnout is quite meager, and I hope that's because there are lots of people watching at home, but we'll see. You're here. Are you not watching at home? Are you sure? So once again, we're doing this experiment, and today we're actually running, so there we go, we're online. Now, there are a couple of things I have to tell you. Admin things. Speaking of, I can get a sound. I'll just switch off my sound, otherwise I have feedback. Now, I said we're going to talk about a few things. We have to talk about the test a little. We have to talk about the project, because I promised several people we do that. And if we get to it, we have to talk about the performance. I mean, we're still talking about performance this week. And we have to watch our little Friday video. But because of this Google Hangouts, I didn't prepare that. And I'm not sure if I want to share the videos in Google Hangouts. So this is part of the class after all. But I'll make up for it on Monday. So we can watch our little video on Monday. And today we'll just get down to talking about those three things. So, firstly, the test. I know I'm way behind on the website, but I've started adding the solutions to the tutorials. 3 and 4 are not completely done, well, they are partially done. But if you go in here, you'll find a short discussion and then the actual solution that I implemented. It doesn't mean it's the only solution. I mean, you can have different solutions in your when you did that. If your solution doesn't match perfectly, it's fine. But even if you did it easily and you found that it was an easy problem to do, please have a look at these files. I'm not going to show you one now, but they are there. And just have a look at the code. And it's a very important skill to be able to read other people's code. So once again, test is on Monday. It's at 7 o'clock in the evening. It's in this building in room 107. Is that right? Let's just double check. Oh, look, all the big pictures. That's our classes. That's the marks. And here we go. So 7 o'clock on this Monday, this coming Monday, in 107. And what will be in the test? It will be all the stuff we talked about in class, plus the tutorials. So I am going to ask you to write some code on paper for the tutorials, as you did in tutorials. And they're all based, just as the written tests, they're based on the tutorial problems. I'll not ask you something very difficult. I'll not ask you something that takes hours to write, but I do want you to write some code. And I'll ask you questions like, what's the difference between static and final? That kind of stuff. Let's see how the written test goes. Here is my assistant, my lovely assistant, Daniel. And he's going to monitor the Hangouts. So just give us a sec to set this up. Daniel, do you have a smartphone with you?
Yeah.
Okay. Could you please go, you've been invited to a Hangout. Yeah, switch off Candy Crush.
Sure that you showing the whole desktop. You've actually just seen the.
Okay, hang on. So there's a small issue. This is we're testing, so
Go ahead. Share. Ah. Let's choose this.
ah,
There you go. Then I can show everything.
okay, excellent.
Oh,
don't-
obviously it looks weird now. But
That's fine. It's a mirror effect. So
it's working. The sound is coming through.
Okay,
And, now we'll just test if this desktop's coming through.
okay,
And there's somebody out there actually.
there's someone out there listening to us on the internet.
Cameron actually.
Cameron, the Prime Minister of the United Kingdom, is listening to us. I already sent you the invite. Can't send it again. Okay. Well, go ask JP and Farid to connect you up. Okay. And this is Kendall. He'll be monitoring. He's not a demi, but he'll be monitoring the question. So just so that I'm not distracted by having to look at the screen all the time. So as I said, the written test, what we did in class, what's in the tutorials. Is there anything else you want to know about this test? Yes, there is something else. Do you have to know JUnit code? You mean have to be able to write? Yes. No. I mean, I get this question all the time from even the other students like Kenil. Do you have to write correct code? Well, yes, you shouldn't make mistakes in the Java code, but you've been writing Java all the year, and I expect you to be able to know Java. But I don't expect you to be able to write import org.whatywhat.unit.assert.whatywhat. So all those imports, I mean, that's not important to me. I don't know the imports. I mean, I don't know what I have to write at the top of a JUnit test. And I don't know the correct package for the Sedgwick and Wayne libraries either. So it's edu, Princeton, CS, something. I don't know those, and they're not important to me. So, but when you write a for statement or an if statement, that kind of stuff should be right. And I'm not going to ask you to write JUnit tests, even though it's trivial. Even though it's just add test at the start of a method and assert equals or assert this and that. I won't be asking you to write the unit tests, because we haven't really been doing that in the tutorials at all. So let me tell you what I'm going to do. To set this test, and I haven't yet, to set the test, I'm going to look at the tutorials, and I'm going to pick 2 or 3 problems that seem reasonable, that I expect you to have been able to do. And I'm going to take them and modify them a little bit, or perhaps just take an excerpt and ask you to fill in some missing code, something in that line. And then I'll also be looking at the most important things we talked about in class and ask you questions to make sure that you know that. Daniel, are you connected yet? Are you coming? Your Gmail address is Canel. Let's not reveal that to the world. Okay, let's just. I'll just do a quick check to see if anyone has. I am watching. Hello. Okay, so nobody's asking questions. That's fine. Any other questions about the test? Everybody's happy. Excellent. Let's talk about the project. Oh no, someone has a. Oh yeah, sorry, I didn't see your hand. How long is the test? The usual time. 2 hours. 2 hours, not 3 hours. I'll give you 2 hours. But in general, in my tests, people don't write the whole time. So there's always someone who finishes after 10 minutes and everybody hates him. And so look at me, I'm so good, and he leaves. And then most people tend to leave after 1 hour. People feel that I've done my part, I've written all I can, and you are going to have enough time. So don't stress about that. Did you write written tests in the first semester? How did it go? Oh, perhaps I should go look at your marks. In computer science, written tests are important, but practical tests are much more important. So remember that a week from yesterday, we have a practical test. And it's the same thing. I won't be asking you questions about what's the difference between static and final or anything like that, but I will be giving you TATs, basically a tutorial that you have to do on the spot, on your own, without help, and you have to hand in at the end. And we'll organize the handing in. And remember, so there's no fifth TAT. It's only next semester. Next week, Thursday, we'll be doing our written test. And the week after that will be the project demo. And people have sent me email, or have sent me email about scheduling the demo, because apparently people have other subjects in that time. But we'll sort that out at the start of this, on the 1st of September, the start of that week. Right. And it's not a big issue. But we can sort it out then. Everybody will have a spot. Everybody will find a time. But let's talk about the project. So, hang on. Let me just find it. Environment project. Okay. So this is still the project. Just give me 1 sec. Can you hear me when I speak from here? You can try from here. No. Oh, I have to stand here. No. Right. Okay. So about the project. Does anyone have? Let's start with your questions. I have lots of questions, but let's start with your questions. Does anybody want to ask anything about the project? No one wants to ask anything. Oh, no. I didn't see your hand. I'm sorry. When's it due? Why? When is it due? It's due in the demo. So I want you to, I don't want to switch back to the schedule now, but I want you to hand in that project right before the demo starts, so at 1:59. By then you should be finished. If you're still writing code in the few minutes before you actually demo, then there's a big issue.
You should have seen also.
Maybe, but I know you guys. You are diligent. You work ahead of time. You probably. I know that most of the class, perhaps not you, but most of the class have even read the rest of the textbook in preparation for my lectures. Yes, they've done exercises, working study groups. They spent nights in Narga just coding up, practicing their programming, because they want to become really good programmers. So the project is due right before the demo starts, and then you can relax for a few minutes, and then you'll be...
I'm through.
Use your reading skills, Casual. Switch the sound off or turn it down. Just put in the little... Oh, that's beautiful. So, Kenny, you'll have to shout, because I may not be looking at you. And if someone has a question, I want to know about it. You'll have a few minutes, and then what we'll do is we'll make... I'll tell you exactly what I'll do. We'll make up a schedule. So you'll have some time slot to go to a demi, and that demi will go through a secret checklist that I've given him or her. And all of the demis happen to be male. I'm sorry about that. It's an issue for me as well. I'd love to have some female demis, but we just didn't find any. They'll be working through a secret checklist that goes through your code and asks you questions to make sure you wrote the code and you understand the code, and you can make modifications to the code on the spot. But essentially, that checklist is just an elaboration of this. So going through the application, seeing that the layout is perfectly correct, and that canvas clicking works, you can save images, and it actually generates the right kinds of artwork. So Josh, where's Josh? Oh, there you are. I'm sorry, I didn't recognize you with your beret. It's very French. Do you speak French? Oh. Zut alors. Okay. Josh asked me, he showed me his art, and he seems to be finished with the project. Or most people are finished with the project. Perhaps you're not finished? Oh, no, okay. Most are finished. Josh is art didn't look like the art on here. It didn't look like this. This, like so. So there happened to be a good explanation for that. He was just using some different parameters somewhere. But we'll be roughly looking for this kind of pictures as well. And if we don't see them, we'll ask you, okay, well, you see you've made the depth 20, so you're generating these long expressions, but just turn it down to 6 because I think these were made with 6, and so we can see that the pictures match. They won't be exactly the same because remember, all this art is randomly generated. That's the whole idea of the project. If you can think of the whole of art, the Mona Lisa, the Last Supper, Jackson Pollock's canvases with that splashing paint, Rodin's Thinker, that little statue, all of that is available to us. We can probably build an expression to generate all that art. And what we are doing now is we're allowing the user to navigate through this entirely enormous space and click on the pictures they like until they eventually get to something they really like, and then we can sell it to them. Save the image, we sell them that image. And it's entirely possible that if they just click long enough, they'll eventually see the Mona Lisa on this little art explorer, and they'll click on that. And then they click on the one where she only has one eye in the middle of her face, and then they save that, and that's the image they want. Okay. So that's where we are, where we're going. Right. Anything else about the project? Your hand was up first, but now I kind of forgot your name. Baveen. Baveen's name is easy because it's unusual, but your name is like common, isn't it? Everybody has a name.
Scott.
Scott, yes, almost everyone's called Scott. Every Tom, Dick, and Harry is called Scott. Yes, Scott.
Like, is it possible if I'm not the greatest programmer to go?
That's
like,
fine.
How would you go through this project? I've only looked at the framework.
You want to go through it?
Yeah, I've just looked at framework. I don't know where to start. I don't know how to go. I know this expression and all that, but I have no idea of anything.
You have no idea of anything
Of how to get going.
of how to get going. Okay. I'm not mocking Scott. I'm just trying to figure out what he's saying. So let's just start. Let's ask. Scott volunteered. He'll be a victim. So let's just work through Scott. Scott, did you do this exercise in the first? Say again. You got it. Yeah. Let's start. Let's keep that. But did you implement this? No chance. Okay, we have a small issue. Okay, but the idea of this first exercise was to teach you, in a small way, that we are going to draw pictures like this one. Yes, and the way we draw it is by iterating over this image, so going line by line, pixel by pixel to each line, and evaluating these three functions. So we have three functions, three separate functions. This one's for red, this first one. The second one is for green. And this last one is for blue. And you can see it takes an XY parameter. So these pixels are on a much larger canvas. Let me find my other technology. Okay, now we're going to switch for the very first time to this screen on the Google Hangouts, and we'll see if it comes through. Do you receive my broadcast? Well, Canon does. Okay, never mind. Here we go. Right. So today's the 22nd of the 8th, 2114. This is page 1 for RW144. Excellent. So we're trying to draw this canvas, Scott. And it goes from 1 to 255, let's say. I'm just making this up. I forget how big the canvas actually is. And every pixel here has some address. So that might be 200, 300. To find the pixel, the color for this pixel, we are going to evaluate our three functions. One for R, one for green, one for red, one for green, and one for blue. But we can't put those values in because our functions are all based on the assumption that x and y go from 0 to 1. So before we put the 300 and 200 into these three functions, we just have to convert it. So we have to divide each of these by the canvas size. So when x is 0 at the left margin, you paying attention, Scott? Okay. When x is 0, divided by 512, we'll get a 0. And when x reaches this right-hand margin, we divide by 512, we get 1-ish, almost. So x and y are now guaranteed to be between 0 and 1. So that's the first little step. So we iterate over the whole canvas. For each point, we call our three functions, and that sends back a value. Let's just make up a value, 1, 2, 8, 50, 10. I use these three to construct a color, as we did before many times. And that's the pixel I want to draw in that spot. That's the color of this pixel. And I just work through all the pixels in the canvas. And you should, I know I've told several people I put up the correct image here, but you'll get a picture like this one, or like the pictures on the art project. Yes. Daardie funksies. I'm sorry. I made a big mistake. Scott, why didn't you stop me? I made a big mistake. You're absolutely right. Thank you for reminding me. These are not from 0 to 1. Backtrack. They are from -1 to +1. So this formula is wrong. Oh dear. Help, Scott. What should I do? What's the formula, Scott? Oh, well, come on. The whole of math. Or just the head of department. Or... Oh, that's math. Oh, math. Oh, I thought you said math. Oh. Come on, Scott. This is like high school math. I have a value, and I've already shown you how to map these values that go from 0 to 512. I've shown you how to map them from 0 to 1. But that was a big mistake because these functions, and like I said, the functions are defined for -1 to 1 for x and -1 to 1 for y. So we need a new formula, Scott, to map that range to -1 to +1. And you need to help us, Scott. You are our only hope. Yeah, I mean the pixel x, the original x is going to start at 0 and go up to 512. I think you're just flustered. I mean, you're afraid of the spotlight. You feel the immense pressure, not only of the whole class listening to you, me listening to every word, but the whole world watching you on YouTube and listening to your so-called answers. Okay. Okay. So, Scott, let's try something. Okay, let's try something else. Let's say that Ken was saying I'm too cruel, but it's fine. Scott will survive. He's a big boy. Okay. So I'm going to call my function m. This is my mapping function. So m is for mapping. Before, I just took x and I divided by 512, and that gave me a value from 0 to 1. Okay? Scott, what would happen if I defined a new mapping function that divides x by 5256, which is half of 512. Where would my values go now? Okay, excellent. So now I've got values in the range 0 to 2. If x is 0, the original x, then this map mx will be 0. And if the original x is 512, then the new mx will be 256, 2, as you said. Okay. And one more step, Scott. I know you could do this. How do I change 0 to 2 to -1 to +1? Excellent. Okay. So just subtract 1. And this will convert my pixel coordinates to xy coordinates in the range -1 to +1. Scott, do you understand?
Yeah.
You're happy?
Yeah.
Okay, excellent. Okay, now back to your question. Say your name again? I forget. I'm so sorry, I forget your names. It's so easy in the touch when your names are on the screen. And you know, you only get to know the troublemakers in class, Francois. But this Francois, your question was about sine and cosine.
Values between -1 and 1.
Yes.
Now, do something between 0 and 55.
Oh, you're right. We have another big problem. I mean, these functions will be something like sine and cosine. So they'll also send back r of x and y will be something in the range -1 to +1. Damn, if only we had someone who knew something about mapping, Scott. Okay, somebody just help. Scott just passed out. Somebody just help me. Okay, right. What do I want? I mean, R is supposed to be the pixel value. And what does that color API take? I forget. Oh, these things are so tricky. Java API color. Let's go to the documentation. Let's see. Let's see. Oh, please don't tell me. Oh, oh. Are you guys still picking me up? Okay, but I'm back on again, so here we go. Okay, and I'm still broadcasting, so that's fine. In fact, I can see my voice volume here. Do I have to screen share again? Let's just see. No, everything is still beautiful. Fine. So a small interruption, internet went down, but we're back up. I was going to say that we now have these values, Rx and Gxy and Bxy. Return these values from -1 to +1, but we really need them to be, I mean, this is the constructor I use most often. It takes 3 integers, RGB, and it needs to be in the range 0 to 255. So now I need to go from this range -1 to +1, to 0 to 255. So let's just do Scott's trick in reverse. If we add 1 to this function, if I add 1, oops, my mistake. If I add 1, I'll get something in the range 1 to 2. So RXY sends back a value from -1 to +1. I add 1 to it, and I get something from 0 to 2. But I really want to be in the range 0 to 255. So I'm going to multiply this by, Scott, you're the expert. What do I multiply by? Ooh, but if I multiply the 2 by 256, I'll get 512. And I really want to be in the range 0 to 255, 256. Multiplying by 256 will give me a range that's exactly twice as large as the one I want. What's half of 256? Okay, 128. Listen, let's digress for just a second. If you're a computer science student, there are some numbers you must know. You must know them intimately. Much better than you know your boyfriend or girlfriend. When I say intimately, you know what I mean. So, what are these numbers, Scott? Let's go through them. 1, 2, 4, 8, 16, 32, 64, 128, 5, 256, 512, 1024. These are the powers of 2, and whenever you see them, you should recognize them as your friends, secret handshake, all that. The first 10 are enough for the first year, but when you're in second year, you learn more. 2048, 4096, 8192, and so on. Okay, that's all the second year numbers. Okay? But for first year, you need to know these numbers and be comfortable with them, so that you know instinctively that the half of 256 is 128. I mean, these numbers are all familiar. I mean, why these numbers? What the hell, man? Why these numbers? Why not powers of 3? Oh, just don't know. Well, this is exactly the numbers that will fit into 1 byte on the computer. In 1 byte, I have 8 bits. You must have learned this in the first semester, did you? I know you did. And in here, I can store all the numbers from 0 to 255. So I can store 256 different numbers, these numbers. So these numbers are always important to us. Sorry, you're going to ask a question.
Should we multiply by 127 in case we have an hour bounce, or 2 times 128?
No, because we won't really get exactly 1. It'll always be slightly less than 1. You might get some issue. But very good question. But let's try this and see what happens. Okay. I'll tell you what will happen. If we do happen to have exactly a 1 here, and we add 1, we get exactly 2 here. And if we multiply by 128, we get exactly 256. And the color API says that the value should be from 0 to 255, so 1 less than 256. But if we do happen to give a value that's slightly too large, the computer will actually not complain. It will just cut it off. It'll either cut it off at 255, or more worryingly, it will wrap around to 0. But both those cases are fine. We can survive. And that's a very detailed issue which we can address later on. So, Scott, are you happy now? Okay. I'm not finished with you. So that's the first part. That's the part about, let's just check if Google Hangouts is still happy. Yes, it is. Okay. So that's the first part. That's the part about taking 3 functions like this and drawing a picture like that. And once you can do that, you've completed 1 part of the project. But the second and trickier part, which I know people have questions about, and I don't know why they're not asking them, is this part about the expressions. So the part that talks about taking, so let me just find the exercise, taking an expression like that and creating a different class that will represent a different function. Julian, do you want to ask something? You do? No, you don't. Daniel, do you have questions? Okay. So, where do we get these? Give me a sec. Where do we get these functions from? Where do we get the RGB functions from? Where do they come from? And more importantly, perhaps, they must be different for all of these 9 artworks. We can't use the same RGB functions to draw each of these artworks, because if we use the same functions, we get the same artwork. And all 9 artworks are different. So the idea is that each of these is a different artwork. And each artwork stores its own 3 functions. One for R, one for G, one for B. The one in the middle, the original artwork, its 3 functions are generated randomly using this algorithm that's here on the page. There's a big algorithm here. Scott, did you see this? Not exactly. Yeah. Constructing a random expression. And that explains to you how do you construct a function, one function, randomly. Now you need to do this 3 times for RGB for the original artwork. Yes. Chris, nee, Jan. Johannes. Is your name Johannes? No. Marco, I'm sorry. Because it's not on the screen. Yeah, Marco, yes.
En daai function proses gebeur waar die 2 keer average gebruik wat die product.
Yeah, I know. Small typo, and I'll fix it almost immediately. Okay. So there may be a typo here. There. That should be product. I promise to fix that now. Let me write it down. When I get back to my office and I put these notes online, I'll fix that. But in essence, this algorithm tells us how to make one function. We need to do that 3 times for each artwork to get the RGB, or at least for the original artwork, to get its 3 functions for its RGB. And then these other 8 artworks take the original artwork, they take its function or functions, and they use the second algorithm. So the first algorithm, this whole story is for how do you make a random expression. And then below it, there's a second one, how to make a random variation. And the random variation starts with an expression, and the algorithm tells us how to modify that expression to get a new random expression that's just a slight variation of the first. So what you'll do is when you start up your program, you'll generate 3 random functions for the original artwork, and then for each of the 8 neighbors, you generate a random variation using that little algorithm on the page. Do you get that, Scott? You do?
I got that.
Are you sure? I just want to be very sure, because it's easy in class to think you understand something, but not, at least that's not, for me that is. Okay. So that's the second part. Just understanding how all that glues together. Okay. Let's talk about 2 more questions. We still have time. 2 more questions. One is, how do I store these functions?
Just repeat the questions that the students ask.
Yeah, I shall. In the future, I shall repeat all questions people ask. You're supposed to know that. How do I store these? How do I store an expression like this? I mean, the central artwork has to store 3 of these functions. How does it represent it? And the answer is.
They're not seeing that.
Okay. I'm pretty sure I'm sharing my desktop. There we go. Okay, it'll take time to sort out these technical stuff. This technical stuff. In fact, it looks to me as if we'll have to have someone here in every lecture. Not you necessarily, Caniel. Caniel hates being here because I'm punishing him for something he's going to do in the future. I haven't decided what yet, and that's why he's here so early. Okay, so how do we store these functions? Well, we have these classes that can represent these functions. I have a class called sine, and I have a class called average, and I have a class called cosine and sine, x and y, and product. And to store a function, I create an instance of this class. So if I want to represent the sine function, let's say just sine of something, I create an instance of the sine class, and I store that instance. And remember, and when I store an instance in Java, I say that it's not. I'm not really storing the. I don't really have space for the class itself. I'm merely storing a reference to such an instance. When I created the sign instance, I asked Java make a new sign, and it said, okay, I'll make some space somewhere in memory. I'll put the sign instance there with all its field variables, and I'll give Yaku a pointer to that sign instance. Sign takes an argument, and that's another function of x and y. So sign's operand will perhaps be pointing to another such function, so that they can be nested. That's probably the trickiest part of the project. So if you don't understand that, you must tell me so that we can be sure. Is everybody happy with the idea of the representation of these functions? No, people are not happy. Okay, do you have a question? Oh, sorry, before you carry on. I know what you are thinking. You are thinking, I don't understand this at all, but I don't want to look stupid. I'm the only one in class who do not understand it. That is almost always false. I promise you, if you don't understand it, no one understands it. So don't be afraid to ask questions. You are never the only one. The others are just too scared to open their mouths. I promise you that. And that's fine, but someone has to do it. Yes, you don't understand. You think it's going to sound stupid, but yes?
Like the sequence of each expression. Like how would you store the sequence? Like
The sequence, yes.
Sin of
So let's just take a simple expression and see how it's stored in memory. I'm not going to generate a random expression. I'm going to construct it by hand. And I'm going to assume that you've already written the classes. So I have a sine class, and I have a cosine class, and an average class, an x and a y class. And let's write code to construct the function. So I'd ask Scott which function he wants, but he'll just panic again. So instead, I'll just pick one myself. How do we store a sequence of these nested functions? So I'm going to choose the function. Yes. No, screen share is on. I'm not going to do this all the time, Canuel. Screen share is on. You should be seeing what I'm seeing. You see it? Okay, right. This is going to be the worst YouTube channel in history. Okay, right. So we have a function we want to represent, and I'll be choosing the function today. And my function is the average of the sine of x and the cosine of y. I want to store that function. It's my R or my G or my B. I'm not telling you which one, but that's the one I want to represent. And I'm not going to construct it randomly. I'm going to construct it by hand. You're not going to write this code, but if you had to, this is how you would write the code. You'd say, I want to store an expression. Now remember, expression is a superclass, and all these other functions are derived classes. They inherit from expression. We're using object orientation. So my function is an expression. Called f. Oh, I've just made a big mistake. Oh, never mind. It's fine. My function is an expression. That's a variable declaration. So if I just say that, Java will say, okay, Yaku wants to store an instance of an expression called f. So I'm going to find some place in memory to store f. But I'm not going to store the whole expression. I'm just storing a pointer to it. So it's really sitting somewhere else. And when Yaku creates that instance, and we'll allocate the memory and we'll point to it. So for the moment, this will be null. So it's not pointing anywhere. But now, this is the expression I want. So at some point, I'm going to write f is a new instance of average. And my average class, I've defined it to take 2 parameters. And those parameters are also expressions. They're sub-functions. So I need to pass 2 sub-functions to average. And for now, I'm going to call them G and H. I know I haven't declared them, and I know you don't know about them yet, but I'll call them G and H. When I say this, Java's going to say, Jaco wants a new instance of the average class. So I'm going to find some memory somewhere. This is an instance of the average class. And it takes 2 parameters. Jaco's implementation has a left field and a right field. And the left field is going to be G. But I'll just write it like this for now. And the right field is going to be H. And he wants to store that in F. But now we have an issue, because this is an instance of average, and F can store pointers to expressions. But we did this in class before. Average is a kind of expression. It inherited from expression. So it's fine for F to point to average, because an average is a kind of expression. Average extends expression. So F can point right here to this instance. What about G and H? Well, G needs to be this function, sine of x. So I should have declared it before. I should have declared G before, here at the top. And if I do that, Java would have made a place for G. It would have been null. F is no longer null. And I would have said G is a new instance of the sine class, and it takes some parameter, which is x, but now I'm going to write I. And when I write this, Java would have said, okay, a new instance of the sine class, Jaco's class only takes 1. It has 1 field called upper. I needs to be stored there, and we're in the same kind of situation. This assignment will mean that G will be pointing to sine. And when I pass G to average, average will actually put a pointer to this instance in that G field. And the same for H. I'm just going to write quickly because our time is running out slowly, but surely. So new cos, J, H would have had a spot somewhere in memory. I'm going to put it down here. Upper is J, and this would have pointed here. Of course, H would have pointed here as well. It's 2 minutes. I have to go fast. And I and J, I'm just going to do I. I would be a new X. And as it happens, X does not take any parameters. It's an empty constructor. So I end up with something like this. F points to this average instance. I'm going to redraw it so that you can see the whole picture. And I'm going to draw it slightly differently. It has a left field, which points to the sine instance. And that has an upper field, which points to the I instance. And its right-hand side, the right field, will point to this cosine instance. I'm just redrawing it so, oh, you can't see perfectly. Just redrawing it so that we get the nice picture that's also on the project page. So now, F is pointing to this whole tree, which represents my original function fx. There we go. I've just created objects, instances, to represent that function. And when I call the evaluate method of this of f, this average, with some x and y, it'll say, okay, to evaluate average, I need to evaluate my left-hand side with x and y. I need to evaluate my right-hand side function with x and y. They'll return 2 values, both from -1 to +1. And I average those 2 values, and that's the value I sent back. And this is recursion. So when average said, I need to evaluate my left-hand side function, it would have passed the x and the y to sign. And sign would have said, I need to pass that x and y to this class. So this has an evaluate xy that just sends back the x value. So the x value would have come back here. I would have said sign of that x, that comes there. I would have passed x and y to the right-hand side, to the cosine. I would have passed it to y. I have to stop. Okay. I don't want you to wait for your next important class. We can talk a little about the project on Monday, but have a go at it. Okay. Right. And I'm going to stop the hangout. End of class.